Hello everyone, welcome to Study Desk. In this video, we are going to learn how to read a chapter. Come, let's start. Mapping the Earth. Mapping the Earth is a little more difficult because our planet is not a flat surface. It nearly has the shape of a sphere. We say nearly because it is not perfect sphere, but is slightly flattened at the poles. However, in the practice, we will consider it to be spherical. Representing a sphere accurately on a flat sheet of paper is not possible. To understand why, peel an orange in such a way that you have just 3 or 4 large pieces of the skin. Then try and flatten them on a table. You will see that you cannot do it without tearing them at the edges. Now consider a globe, which is a sphere on which a map is drawn. This may be a map of the Earth, the Moon, the planet Mars, the stars and constellations in the sky, etc. The physical object, like the one shown in the drawing on the next page, is a sphere that is generally made of metals, plastic or cardboard. Here, we will study the globe representing the Earth's geography. Because the globe and the Earth have the same spherical shape, a globe will better represent the geography of the Earth than a flat map. Let us now explore some of its features. Understanding coordinates. Imagine a big market in a city or town with neat rows of shops, all the size. You want to meet a friend at a stationery shop inside the market, but your friend does not know where the shop is. So, you would give directions like meet me at 6 p.m. at the 7th shop in the 5th row from the entrance. This will allow your friend to precisely determine your location. Now, consider a chessboard. To record moves by advanced players, letters are placed alongside the main pieces from A to H. See the image and numbers from 1 to 8 in between the two sides. This simple system allows players to mark each square and record every move. Here, the white side has just opened the game by moving the queen's pawn 2 squares forward, a very common opening. So, the pawn is said to have moved from d2 to d4. See here, it is moved from 2 to 4. The system used in these two examples may be called a system of coordinates. Thanks to their two coordinates, the stationery shop as well as the chess square on the chessboard can be precisely determined. A similar system of coordinates is used in the world of maps to determine the location of any place on a map. Let us see how this system works. Latitudes. Let us return to the globe. It is easy to identify the North Pole and the South Pole on it. Rotate the globe while it rotates. The fixed points at the top and bottom are the 2 poles. Halfway between them is the equator. Note the circle marking it. Imagine that you stand on the equator and travel towards one of the poles, your distance from the equator increases. Latitude measures this distance from the equator. At any point of this travel, you can draw an imaginary line that runs east and west, parallel to the equator. Such a line is called a parallel of latitude, and it draws a circle around the earth. Again, it is easy to note on the globe that the largest circle is the equator, while the circles marked by the parallels of latitude grow smaller as we move from northward or southward. Latitudes are expressed in degrees. By convention, the equator is latitude 0 degree, while the latitude of the two poles are 90 degree north and 90 degree south respectively. This is noted 90 degree north and 90 degree south. There is a connection between latitude and climate. Around the equator, the climate is generally hot. It is also called torrid. As you travel away from the equator towards one of the two poles, in other words, as your latitude increases, the climate becomes more moderate or temperature, and closer to the north or south pole, the climate grows colder or frigid. You will learn in science why this is so. Also, why we experience different seasons in the course of a year. This figure shows both parallel of latitude and meridians of longitude. Longitudes. Imagine now that you travel from the North Pole to the South Pole by the shortest possible line. Observe the globe. You will see that instead of passing through Europe and Africa, you could just as well pass through Asia. The distance would be the same. These lines are called meridians of longitude. They are all half circles running from one pole to the other. You will also learn in this science that the earth spins on its axis. To put it simply, let's place a desk lamp a little away from our globe, focused on it, and imagine that this is the sun illuminating the earth, slowly rotating the globe eastward. We can note that for some places on the earth it is morning, while for others it is midday, evening or night. When it's breakfast time in one country, it's lunch time in another, and in a third country people are fast asleep. That is why, by measuring the longitudes of a place, we will also be measuring the time at that place. Let us see how. To measure longitudes, we need to define a reference point called the prime meridian. It is also called Greenwich Meridian because in the year 1884, some nations decided that the meridian passing through Greenwich, an area of London in England, would become the international standard for the prime meridian. It is marked as 0 degree longitude. Just a latitude is a measure of the distance from the equator. If you travel towards one of the poles, longitudes is a measure of the distance from the prime meridian. If you travel along the equator, longitude too is measured in degrees. Westward or eastward, it increases in value from 0 degree to 180 degree with the letter W or E added. For instance, using round figures, New York's longitude is 74 degree west, while Delhi's is 77 degree east and Tokyo's is 140 degree east. Thank you so much for watching. Please subscribe.